How many of you have ever heard of Ryder before this? Oh, wow. Did any of you know that we did a lot of other stuff outside of renting trucks? Anybody? Couple of you? So Ryder has a very wide suite arrangement of offerings, but for the energy group, we mainly focus on our dedicated transportation, our warehousing, and our transportation management. It really provides an end-to-end solution for anything that you need, and everything is completely customizable. So where I'm really going to spend the bulk of my time today, and not going to spend too much time on it, is to talk about what we do for our customers from a safety contract management situation. I also have Ashley Aiken with me here from Chevron, and we're going to kind of give you an introduction into material transfer. But what we do for Chevron, what my group does, is we actually manage contractor safety. That's what we do. So we are doing everything from procurement to bringing on carriers, from an onboarding process to continual improvement. So our team goes out in the field and actually checks the trucks out in the field. We provide scorecards and feedback, back to our motor carriers and back to our customers. And when Chevron brought material transfer to us, it was a large struggle to get that out to our water carriers. I'm sure all of you that are water carriers bond or ground your trucks, right? So with material transfer, we actually have to ground and bond. We have to have conductive hoses, and we have to check that we have continuity through that entire system. So Ashley's going to talk to you about why we have pushed this material transfer standard and why it's important. I guess we don't need that anymore.
Probably don't need a clicker. Hey everybody, as Alena said, my name is Ashley Aiken. I work for Chevron. I'm part of the Mid-Continent Business Unit. I'm an Operations, Health, Safety, and Environment Manager there. So as Alena was explaining to you guys, material transfer. Who is familiar with Chevron's material transfer standard? Oh, that makes me happy. I love it. So as you all know, we are kind of the ones leading the pack on this one, and we're really hoping that others step in on this. For those who aren't maybe familiar with it, you had mentioned grounding and bonding is a requirement, conductive hoses, continuity testing. So it is more work, but it's for a reason. So next question to you guys. Can you all tell me why the OSHA standards and a lot of the health and safety regulations came to be, how they came to be? Anybody? Somebody got hurt, right? It's written in blood, I think is the saying that as it goes, right? So it's no different with our material transfer standard. Back in June of 2011, in our Pembroke refinery in the United Kingdom, we had 4 people that were killed and 1 person that was severely burned. That made an impact on us, right? An investigation was done. We looked at all the safeguards that we had, and we didn't have enough. We had to come up with something else. So that's when material transfer standard was born in our downstream facilities. So downstream had this material transfer standard that they used all across the refineries. And then we fast forward about 7 years or so, we get to Permian. I actually was working in this particular field where we had an incident. It's about 50 miles or so south of Midland. We had a vac truck that had a static discharge and lit off a tank. Fortunately, no one was injured. But same story as what happened at Pembroke. Static discharge and explosion occurred, right? Ours was very minor compared to Pembroke's, but we realized that we were very susceptible to this too. We, as Chevron, had not adopted a full enterprise-wide standard. It was just downstream. So we got to look and we were like, okay, we've got to come up with our own safeguards here. So we very much looked at downstreams and an API standard that had been developed, I think 2219, API 2219. And so the Mid-Continent Business Unit Chevron material transfer standard was born. Since then, that was in 2018, I think was when we first said, okay, let's do this standard. Rollout happened in 2020-ish. We all know 2020 was a bit of a rough year for us all, and the rollout was not great. So we re-looked at it, worked with Ryder really closely, and found some ways maybe we could improve it, and re-rolled it out in 2021, and we've been on that journey of improving it ever since. And then actually October of this year, so last month, Chevron Corporation rolled out an actual enterprise-wide material transfer standard. So that's our journey so far. Love it that we've got some people on this journey with us and that Ryder's on this journey with us.
So last thing I'll say before we introduce Mike with Newsom Gale is, as you can imagine, anytime you change or ask for additional requirements, it gets difficult for drivers, right? We already ask our drivers to do a lot of things. So this wonderful product that Newsom Gale is going to show you, is, if you're somebody in the water space, is a way to engineer that out of your business. So that the driver actually doesn't have to do anything and you don't have to rely on the human portion of it. So, Mike?
Thank you again. Thanks for the Permian Road Safety Coalition and Ryder for having me. As she said earlier, this is a record for the event, so if you indulge me for a second, I think I'll take a groupie with everyone. Good deal. Again, thank you for the opportunity. I'm Mike Elias. Oh, can you hear me? Better? If we have any problems on the clicker, I can get a little closer to you. Regional Manager for Newsom Gale. I handle static grounding and bonding for hazardous areas. Some of the industries we serve: paint and coating, pharmaceutical, food and beverage, and the chemical and petrochemical industries. Some of our global approvals and certifications, not all of these in North America, but and just a few customers. What is static electricity? We've all had that example when we were younger, running across the floor to your parents' house with your socks on to go shock your sibling, right? Two substances rubbing against each other and they become unbalanced. It's a simple explanation. The charge usually stays there until it dissipates or it's grounded to ground, or it neutralizes to a discharge, sorry. It's called triboelectric charging. There's two objects that rub against each other, and when they separate, they're out of balance. Practical example here is you have a hose on a vac truck, running methanol through, high velocity, it becomes unbalanced and can emit a charge. The energy of that spark depends on its capacitance, or the mass of the vehicle, right? And here's just a few common things that we deal with on an everyday basis. You can see a half-inch bolt has a capacitance of 3 picofarads. And let's not get caught up in all the measurements here, but everyone can visualize a half-inch bolt. That half-inch bolt can produce an energy of 1.5 millijoules. Here are some of the hazardous products we deal with on an everyday basis, and a minimum ignition equivalent to ignite those products. So you can see it doesn't take much for those to ignite. The problem with static electricity, you can't see it, can't touch it, can't smell it, and unfortunately we have a feeling like it won't happen to us in the industry. How do we mitigate against static electricity? Well, at Newsom Gale, we have 3 layers of protection. One is just simple clamps and cables. It's Senstat. You see it everywhere. Facilities, back of trucks, and some of them are homemade. Our next level of protection here is Bond-Right. Our Bond-Right is just visual indication. It measures that we have a good connection of less than 10 ohms from the clamp back to your ground, and it continually measures that. It gives you a visual indication. And lastly is Earth-Right. Earth-Right is not only visual indication, but it's our interlocks, has interlocks and intelligence. I'll mainly be talking about Earth-Right, our Earth-Right products. Our Earth-Right products fall in the 4 and 5 categories. But today, for our examples, we'll be dealing just in number 5, which is our intelligent systems. The first system that we'll talk about is the RTR. Our RTR is a road tanker recognition system. It has tri-mode technology. The first thing it does, and the reason I brought up capacitance, is it checks for capacitance of the truck. There's no cheat in the system. You clamp it to a wheelbarrow or a forklift, it's not going to recognize the capacitance of that forklift or wheelbarrow, and it will never go permissive. Second, it will check for a ground for less than 1,000 ohms in the system. And the third mode that it does check, it continuously ground loop monitors for less than 10 ohms throughout the process. Just a quick example. Here it runs through the system, down the ground, up back through the truck, and checks for 1,000 or more picofarads of capacitance. If it doesn't have that, it will never go permissive. Here's a second check. Again, through the ground, back up through the truck, through isolation, and we're checking for 1,000 or less than 1,000 ohms for a good ground. And here is a continuously group monitoring from the system to the clamp, back through the clamp, through the system. There we go. For less than 10 ohms. You connect to the truck, the first thing it does is check the capacitance, verifies ground, and continuously checks for less than 10 ohms connection throughout the process. This also has interlocks. If the system should not go permissive, those interlocks would close and shuts down the process. That's another safety feature. I mention this because this was one of our first systems that we developed several years ago, and the field came to us and asked us to come up with a mobile version of this. So we basically used the same technology, and we came up with the MGV, which is the mobile ground verification for vac trucks especially. Vac trucks can have an accumulation of static discharge if not grounded, and very time consuming if you're having an electrician going out there to check your ground. You can see here's a non-conductive product going through a conductive product and could make a charge very quickly. And we'll go through that real fast. So what are the risks? As you can see, voltage is accumulating on the truck. If we're not properly grounded, a spark could, give me a second. Ignite. There we go. So this whole area is a hazard if it's not grounded properly. How fast could it charge? A spark, in reality, could discharge within 30 seconds, up to 15,000 volts through a spark gap of 5 millimeters, which is about 3/16 of an inch. That's how fast it can happen. How do we find Earth? How do we find the ground? We have some remote locations a lot of times that we don't always have a designated ground. Some of our facilities, some of our major facilities across Texas, Louisiana, mainly, will have a primary grounding point, tested by electricians periodically so that is never an issue. But we do get to these remote locations where we might have to find a secondary ground, a pipe in the ground, an I-beam, a building. Some of these have to be tested. But you can find a ground in some of these remote locations. We provide a temporary grounding point if you're really remote. Comes with 4 electrodes and cables. It has been really useful for our hazmat recovery and vac trucks in general. Some of the other factors in trying to find a good ground, obviously, is earth or soil conditions, moisture, how wet the soil is. You can see that. You can see here that the drier the ground, the more resistivity you have. It's going to be very hard for you to find a ground. Ground temperature is another factor. As you approach 0, the resistivity goes up as well. So trying to find a ground in West Texas plays a big part for you guys out here as compared to maybe, say, South Louisiana. Our electrode condition, if you have a rusted or corroded electrode, that could be another factor in trying to find a ground for your vac truck. And the depth of the electrode. I have a lot of slides, so I'm trying to move kind of fast to make up some time. So the first thing that you do for our MGV, clamp on first, clamp off last. It's important that we establish that we have a good verification to ground of less than 1,000 ohms. And I'm going to go back to that. It's an industry standard, and we'll cover some of the areas that you can find this in. It is a critical step before you go any further in the process or in your operation. Here's a vac truck. Signal comes out through the junction box to the clamp, down your ground bar, comes back to the truck, checking for less than 1,000 ohms. The next check it does is continuous ground loop monitoring, just like the RTR. While operating, we're looking for a good connection from the clamp to the truck of less than 10 ohms. Both signals are intrinsically safe, IA, which is the highest level intrinsically safety. If both tests are met, the system will go permissive green and it will be safe to operate. Again, I have an animation here. From the system, through the junction box to the clamp, back to the clamp, through the junction box to the system, through the truck, through the grounds on the truck, and we will maintain that less than 10 ohms during the operation. And it will go permissive. If it doesn't pass either one of those tests, it will not go permissive, it will stay red. Sorry, I flipped through that a little fast. Can I go back one? There we go. We always recommend that we use the interlocks within the system. It is an extra layer of safety. A lot of times the customers don't want to be bothered with it, but we do recommend that we do have it. Use the interlocks within MGV. This is the actual picture of our MGV. At rest, you'll see it's just a solid red LED light. After the clamp is connected, you'll see the blue CDI light. LED will start flashing, making sure the system is working. If the system detects good earth and ground, it will go permissive, allowing the interlocks to change over. Safe to operate. If at any point the clamp gets dislodged, it will switch back to red and the interlocks will close. Not safe to work, and it will halt the transfer. Some of our components along with our system Our X90 clamp, stainless steel construction, tungsten carbide teeth, and a pin grip. And just the pin grip just helps with the connection. Also, our spiral cables, static dissipative, ultraviolet protection, safe from mechanical impact, chemical attacks, copper wire, and it meets IEC compliance. Another option there with the MGV, here's a nice application on a vac truck, is our cable reel, retractable cable reel, again 50 foot. It meets all the certifications. I won't go into the details. This came out of the field too a couple of years ago. We've had enough drive-offs in the trucking industry. People were losing their clamps and destroying the operations. So we developed a breakaway connector. Has a male and female connection, and the picture shows a junction box with our cable, quick connect, and our breakaway connector back to our clamp. My only suggestion is if you do decide to go this route, make sure you get a male connector with another clamp so you can replace it after the truck driver realizes he's 100 miles down the road with your clamp. So overall, the MGV is, the customer benefits to this is it's an easy go, no-go operation. You don't need an electrician to check your ground. It checks it for you. Oh, let me go back. I hit the button too fast. And it's always reliable, checks less than 10 ohms, and it always checks your grounds. The last component, we talked about continuity in hoses, is our ohm guard. Again, this is stainless steel construction. Very easy go, no-go operation. We're checking continuity through the hose, which is important to make sure we don't have a hazard and that a spark does not ignite any of our operation. Here's the risk. If this hose if there's no continuity through the hose and that we have separation there, that can ignite the whole operation. What's the difference between an ohm guard and a multimeter? Well, you don't need any special training. It just gives you 10 ohms or 100 ohms connection through the hose. Easy to operate. It's, like I said, a go or no go. Stainless steel construction, steel the tungsten carbide teeth like all of our products. One configuration is like a junction box on the back of the truck here. Signal is sent to the clamp, through the hose, back to the junction box, down back to the clamp. We're testing for 10 ohms there. Make sure we have good continuity through the hose. Another configuration is our hose assembly with clamp to clamp. You'll see this used a lot when we have multiple hoses and we're checking continuity through multiple hoses, which will come from the factory at 100 ohms. Lastly, again, it just gives you a green LED, pulsing green LED light. It's a spot test for continuity. Where else can we look for guidance for static electricity? NFPA 77, API 2003, NFPA 30, and API 2019, which I think was mentioned earlier. That's it. If anyone has any questions, my name and number and email are on the screen.